Hey guys, so this is the second week I'm kind of trying out this kind of YouTube video thing to help you understand what exactly we're going to be doing for the assignments. So first I'm just going to go through a quick run through. Effort 1, that's going to be another easy quick review, and that's mainly just going to be your Punnett squares. So if you understand this example that I'm about to give you, you'll be able to blow through effort 1 with the Punnett squares, and then effort 2, which is going to be the first half of like kind of our evidence main sheet, is also going to be more Punnett squares. So I'm just going to give you a quick example to help you with effort 1 and effort 2, and then I'll kind of go into like 3 different definitions of dwarfism that you're going to be kind of looking into for the actual evidence. One quick note I want to make before I begin is that I would love you guys to finish effort 1 and then share it with me right away first. Then I can give you feedback to make sure that you're doing it right. And then for effort 2, that way I know, okay, you're going to understand the more important stuff that happens during the evidence. So basically this week we're going to be looking at different dwarfisms and miniatures. So horses, chickens, dogs especially, about how artificial selection wise as humans we decided, oh, I really want to look at kind of this, you know, I'd rather have a small little cute dog, or I'd rather have a small little cute chicken if I live in Japan and I happen to be part of royalty, which you'll get into. Or I'd rather have a little, you know, pony or a little horse, and, you know, just something cute. So before we get into that, I just want to show you the example. So let me hold the phone here. So let's look at the problem. We have a green pea plant and it's crossed with another green pea plant. Notice in the upper left we've got big GG times heterozygous big G little g. And we've completed that, or at least I completed it for you so that you know, okay, big G, 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 and then little g, big G, little b, big G. The genotype, if you remember, is 2 big G's, 2 heterozygous big G, little g, okay? And the phenotype, if you remember, is what it actually looks like. Okay, so that would be 100% green. So let's give you the first example. So let's cross heterozygous big G little g times recessive, autosomal recessive little g, okay? And that would be yellow. So here we have big G, right? And then another big G, so big G, little g. Then we have little g, and another little g. So for genotype, we would have 2 heterozygous big G from right here, and 2 homozygous recessive little g here. Phenotype, what is this actually going to look like? Well, if we know little g is yellow, then we know that we're going to have 2 green pea plants and 2 yellow. Okay? So if you can get that, you guys are going to be totally set. Okay? Now, I took this class in college. It was a Greek and Latin roots of medical terminology, and this really helps understand definitions and remember them. Okay? So here are 3 definitions that you need to know for the evidence portion. Pituitary ateliotic dwarfism, micromelic achondroplasia, bradycephalic achondroplasia, okay? Huge, lofty medical Latin derivative words, okay? But really, it's very simple. So pituitary ateliotic dwarfism are just any animal looks normal. It looks exactly like a normal horse, but it's just small. Looks exactly like a normal chicken, but it's just small. Looks exactly like a normal proportional human, just small. That's your basic dwarfs. Micromelic achondroplasia, that's only short limbs. Bradycephalic achondroplasia shortens the head. Okay, so now we're kind of wondering, why is that? What's the difference? So your pituitary gland is what gives you your growth hormones. Okay, so ateliotic is just Latin for failure to achieve. So failure to achieve your normal pituitary gland, which results in dwarfism. So that's just pituitary ateliotic dwarfism. You look the exact same, just smaller. Micromelic. Micro, we all know, means small. Okay. Melic actually means melodic or something in relation to a song. So that doesn't really help us, so we'll move on. Whenever you see achondroplasia instead of chondroplasia, A always means not, okay? So atypical, asymptomatic, okay? Asymptomatic means you don't have symptoms. Atypical means it's not typical, right? So we'll write not. Chondro, that's a Latin derivative for cartilage. Stuff that makes up kind of the non-bone part of your nose is a good example. Plasia is kind of the act of growing. Basically, in Latin, it means to grow. So what do we see now? A, not cartilage to grow. So there's not sufficient cartilage to grow. So that results in shortness of limbs. Bradycephalic, another lofty Latin word, but we'll break it down. Brady is slow. If you've ever heard any sort of like bradykinesia or anything in relation to your heart, it just means your heart is beating slowly. So we'll just write slow. Cephalic, that is the Latin derivative for head or skull. Okay, and then achondroplasia here means the same. Not cartilage grow. So it's not growing cartilage. Slow head. So it's not growing. Not. So then there you go. Shortens the head. So if you understand those three definitions, you guys will be good to go. I hope that helps.